lightning talks. Last time I talked about domain-driven design, introducing very briefly what are the goals, and I started talking about so-called tactical patterns. So how to use domain-driven design to implement our code. Today, I want to take a step back and starting with big picture. I know maybe is more easy to understand and to explain when you have a bottom-up approach. So I want to start with this picture now. There is I give credits to Shimon Shedowski, and I also take advantage to thank Natalio Benitez Palemba that gave me suggestions and interesting insights. Yeah, I want to start with this picture because I know sometimes you feel that DDD, as well as other things in our industry, are kind of buzzwords sponsored by sects of people that try to evangelize you. And well, maybe this is not completely false, because if you think about, there are people that sell books, that organize workshops, that got hired from IT managers for complex projects, so they push to evangelize this knowledge. For us, the story is different because we get paid regardless on whether we apply DDD or not. But this is also good for us because it gives us the freedom to evaluate, to assess, to experiment our all the techniques, methodologies, and tools that we can use in our daily job. And basically, this is what it is. It's just a tool. It's a technique, a tool in our tool. What I want to mean is that I play bass. I'm a bass player, let's say. I can slap, even if it's not true, I suck at slapping. And I know that I can use this technique when I'm playing, I don't know, a funky groove. If I play punk, I can use the pick. But the final goal is not to show my technique, is to participate in making good music. And in order to do this, I apply technique that in the case of DDD is not really something new. Anything was invented here. It's just about collecting already present knowledge, well-known industry standards, best practices, and put them together. And give things a name, because sometimes it's also important give a name to things. And this is ironically also one of the DDD concepts, give things a name. So we should not be scared about the impact on applying DDD in our daily job. And another important principle that very often is underrated is that what we do here is not just coding, not just focusing on how to develop software, but our role becomes more important as engineers, because we use the technical knowledge that we have to bridge the gap there is between the business and the product that we build and ship. So this becomes also our responsibility to interact better with the product, with the stakeholders, with the people that do the job that we are trying to automate, with the people that we are going to replace, maybe in some cases. Well, and how we can do this, to understand, I'll take another step back. Now, actually, I'll take more than one step back, sorry. I want to start from the beginning, the most important laws of the universe, because there are laws in the universe that are immutable, are static, and describe everything in a very elegant way, such as the general relativity that describes the relationship between matter and energy, the Maxwell equations for the electromagnetic fields. But my favorite one, the best one for me, the most important, is the Conway's law. What says the Conway's law is very simple. When a company starts building a software, well, the software eventually will look like the company that has built it. We cannot escape from this. I mean, prove me the contrary. And this is not, it also doesn't work for software companies, actually, but also for product companies. This means that when we build our software, the choice that we have to take are not just about which language to use, provide a good coverage, but also don't neglect dynamics, mechanisms that are activated inside our company. We cannot neglect, for example, that the VP of product hates our PO because has fired him in a previous company, based on a real story. Because all of these drives the communication, the flow information that is inside our company, and also our understanding or how we are modeling our software. And this is the picture, the real picture that we have about the model that I'm talking about. We think that the big picture is made of clear boundaries, elegant, but it's never like that. There are pieces of knowledge spread together inside our environment, and understanding requirements of the software that you have to build means putting all these things together. For example, we have talked about event storming last week. This is one of the techniques that can be used to achieve this mapping. And so we arrive to have the first site of the domain. What is the domain? Is where we make money and how we make money. The domain is the problem, and sometimes and very often is the company that we are working on. We can start dividing this domain into many subdomains, because the company is made of departments, of teams, of different line of products, or even different actors that interact with our product. So making this splitting, we have already a more precise vision on what we are working on. There are many different types of subdomain inside one domain, because we have domains where we talk about things that make really money, and these are the so-called core subdomains. For example, mapping on Glovo could be a customer experience. Take data, take information from the customers, or also supporting subdomains. So these are domains that are not in the main business flow, but there are teams inside that interact with the main business flow, to be coverage support, or generic subdomain that are not useless, but they don't provide business specific information or behaviors. Are important to define how things work in other domain, maybe. When we collect all this knowledge, we already have a clear idea on which are the relationship and how to map business processes upon. And this is very good, because we can start going to a more detailed view of the software that we are building. We start talking with experts of each domain, and talking with them, we start discovering also which are the things that they use in the daily job. We start talking about names, concepts that could be strange for us, but for them are very clear. For example, in an e-commerce product, you can talk with sales, you can talk with inventory, logistics, and all of them will mention the product. What is a product? It really depends on the person who we are talking about. For the salesman, the product is about making discounts, selling to key accounts, and so on. For the inventory, the product is a box, on a shelf, and so they have to find this box on the shelf. For the shipment, the products is important because it has to deliver to the recipient, to the customer. So everyone has a different view, a different perspective of the same concept. This tracks the bounded context in our domain. One thing that is important to say is that the bounded context is not a one-to-one mapping with the subdomains. It really depends. Subdomains could be made of many bounded contexts. This could be reasonable, or also a bounded context can implement parts of different subdomains, maybe for legacy reason, maybe for some modeling mistake. It could happen. is fine, but what is important is that the subdomain is about analyzing the entire domain, is the analysis part. The bounded context is the solution, is the synthesis. And we understand that we are talking about different bounded contexts when we see that the same concept is present, but from different perspectives. We can implement a bounded context with the code, but today we talk about microservices. There is a lot of buzz, but it's not took for granted that we are talking about microservices. This could exist even in monolith application. The bounded context could be a separate self-contained module or Lambda function. So I don't know. We are not focusing on technical details now. We are focusing still on the collaboration between people. And since we are talking about now implementation, we are focusing also on collaboration of developers team that provide this bounded context. And in order to do that, we can find different patterns of collaboration. For example, two bounded contexts could be bounded, bound in a partnership relationship. For example, my team, the GX Fleet Management team, works on the delivery context, but also on the reassignment. These two contexts have shared goals and even the same people that work on both. So they evolve together. And this is important to understand because it helps us to track boundaries and understand how they can collaborate and how to decouple if needed. In other cases, this relationship can be more intimate. They can share the same code, the same concept. For example, the order entity in our domain is very present and every bounded context points on it. This is not always an anti-pattern. Sometimes it's how things should be. But it's important to keep this shared kernel small to provide evolution of this shared kernel in a safe way because everything depends on it. Another pattern that we can find very often are patterns that track a customer-supplier relationship. This means that there is a bounded context that have to meet expectation for another bounded context. It acts as a server. For example, when an order is assigned, the delivery context expects an event, and so we are creating an upstream downstream relationship. The delivery context, the success of the delivery context in some way depends on the success of the logistic context. This relationship could be more strong, sometimes more harmful, because the upstream bounded context doesn't care about the downstream bounded context. It's the case when we use third-party application, third-party APIs, or we have a provider that is bigger than us, and so it doesn't care a lot developing new feature or sending new events, sending new APIs for us. So we have to be aware of this and keep in mind that we are locking in on that and also provide means to have a decoupling to evolve independently. One of these means is the anti-corruption layer, that is the fifth pattern. Anti-corruption layer is more about integration than collaboration, but this means that we create a layer inside our bounded context that maps the information on the other bounded context and let us evolve independently, because if we here change the API, we should change only the mapping code inside the anti-corruption layer. Or things could be more open, more wide, using, for example, APIs, REST APIs, or even asynchronous APIs with documentation that often is done from third-party services or also from internal teams. We call these open source services and publishing languages. But again, this is not about collaboration, it's more about integration. Well, now that we have identified domains, we have identified bounded contexts, tracked the relationship between them, and we can use also this information to track how we have to interact between each other, we can work independently on our bounded context. And having bounded context is also good because inside the boundaries, we can do whatever we want, or whatever we need to do. Last week, I spoke about anemic models, some anemic domains, and I told that they are not always an anti-pattern because there are domains which we don't find behaviors. Imagine a product catalog service. It's just about providing CSV files, plenty of data, uploading them and showing them in a web UI. It's okay. Go for crude models, crude APIs, and keep everything simple. Don't model behaviors, don't use aggregates and stuff that we've seen the last week. We can also use automated tools to generate code. There are, for example, frameworks like Spring REST repositories that automate everything, creating a more simple backend stacks. If we find some behavior, some rule to validate, well, it would be good to keep this rule concentrated in the domain layer, as we told last Wednesday. We can find that I'm running out of time, really. Yeah. Okay. I will be very brief. We've seen this last week. We can use layered architecture, hexagonal architecture, to separate the core logic from what's not important, according to Bob Martin. And we can arrive also to see that the data that we write is very different from the data that we read. And so we can introduce also CQRS that has a very narrow adoption range. But it's important when, for example, we have to provide the summaries, statistics, when we have asynchronous interaction. For example, I found that it's very interesting to apply in IoT application where you have an MQTT message that triggers behaviors in the backend, and then you can render dashboards to show historical data, statistics, and so on. Well, we have seen that in these 15 minutes that are very few, but we have seen how can we use a tool that is just a tool, and we can use this tool to translate real world problems into real working software. And doing this, we can embrace best practices and foster an evolutionary architecture. Well, thanks for your time. Sorry for being out of my 15 minutes. There are some questions.
Yeah, it looks like we have a question already.
Okay. Well, it's from Konrad Komorowski. How do we prevent domains from becoming silos with their own idiosyncrasies? Silos that impede horizontal changes and reduce leverage inside the company as a whole. Well, this is a very good question because this is actually our goal, preventing to have silos in our company. So we can find tools to make people collaborate together. One of the tools, for example, that, as I mentioned the last week, is the event storming. We collect people, we put them in front of a big wall and let them give their perspective of the domain. And collective of the perspective, finding the problems, the bottleneck, knowledge bottleneck, we can provide a shared understanding of everything. Also, to me, it's also important how to improve collaboration with PMs, how we model, how we treat the specification. For example, using user stories, a more feature-driven process, it could be useful because you don't start from the solution, you start from the problem.